good one. Okay, so if I have the limit as x approaches infinity or negative infinity, and I have, let's say, degree n over degree n, meaning the same degree, 2, 2, 3, 3, 4, 4, but the same degree, I have to factor out the degree from both, of course, and simplify it. If I have the limit as x approaches infinity or negative infinity, and this is degree n, and this is degree greater than n, like degree 1, degree 2, degree 5, degree 11, degree 2, degree 6, the answer is always 0, because the denominator is more powerful than the numerator and eventually will take over. Now the third option is when, notice that this is our topic, only when x approaches infinity or negative infinity. If I have degree n in the denominator, but degree greater than n in the numerator, I recommend get the same thing, factor out the degree, not exactly the degree you see in the numerator, and exactly the degree you see in the denominator, not more. Exactly what you see. Treat them as if they are separate. Factor out the degree. Why? Because depending on the sign here, the answer could be, definitely, will be positive infinity or negative infinity. This is it. It's guaranteed. But you don't know which sign before you factor out the degree. And simplify as much as possible. So we had an example like this. This is a simple situation, but I want to give an example like this, and then we'll start with other questions or continue with other questions in the lesson. So for example, if I have limit as x approaches infinity, let's say from x to the third plus 2x minus 1 over x squared minus 3. And this is the situation. See, the numerator has a higher degree than the denominator. It doesn't matter by how much. By 1, by 10, by 11, it doesn't matter. But the degree in the numerator is higher than the degree of the denominator. This is degree 2, this is degree 3. So I treat them as if they are not together. Since the numerator has degree, I'm going to change this into negative infinity. And of course, the first step, I have to show this is negative infinity over infinity. It's an indeterminate case. It has hope. There is no guarantee. Yes, that is the absolute first step. I have to do that. So, sorry, I don't mean to skip any steps. So, the numerator has degree 3. The denominator has degree 2. And as we did before, it's 1 plus 2 over x squared minus 1 over x cubed. Let's try. This times this is this. This, I simplify the x squared with x squared, and I get 2x. Here, I simplify x with x cubed with x cubed, and I get negative 1. Same thing here, 1 minus 3 over x squared. Well, I know, as we mentioned here, and before last time, I know that this will approach 0, this will approach 0, this will approach 0. I will simplify, and the whole thing is x times 1. Since x approaches negative infinity, the final answer is negative infinity. That's the reason why, in this situation, the third case, I had to follow the steps from the first case. Why? Because I don't know what the answer will be. I know for sure it's an infinity, but I don't know which one. And this is the safest way. So once I simplify an x squared with an x squared, I still have an x left, and when x approaches negative infinity, this is negative infinity. Because now this is a simple polynomial. Limit as x approaches negative infinity of x. Well, when you plug in, so to speak, I shouldn't say that, but that's what we think, that these are the terms that we think in. When x approaches negative infinity, x approaches negative infinity. Very good question, Will. Thank you. Is this better? Okay, perfect. Now let's move on to other questions. Anything you have for me, please? Anything? Anything you'd like to discuss? Anything for me? Anybody? Well, if you think of anything, for now I'm going to share my screen. If you think of anything, we'll go back to anything you need. Let me go back here. Okay, so where is my book? Okay, here it is. So we're in the middle of 1.4. We have not finished it. Let me refresh your memory. Let's go back to one of these graphs. And we said, let me write it down. A function is not differentiable, fancy word. What does it mean? I'm going to put in parentheses. It does not have a derivative. This is one way of saying it. Another way is, this is number one, or number two, I cannot calculate the rate of change at that point. Another, or, they all mean the same thing. Or I cannot determine the slope of the tangent line. At that point. They all mean the same thing. When I say a function is not differentiable at a point, I also mean it does not have a derivative at that point. It doesn't exist. The derivative is undefined. Let me put one more, number 4. At that point, f prime of x is undefined. They all mean the same thing. I just want to erase this and put it after. Okay, it does not have a derivative. Or I cannot calculate the rate of change at that point. And let me call it the instantaneous, because it's at the point, the instantaneous. I cannot calculate the instantaneous rate of change at that point. Or I cannot determine the slope of the tangent line at that point. Or at that point, f prime is undefined. They all mean the same thing. When I say a function is not differentiable at a point, I mean all these. Interchangeably, they all mean the same thing. So a function is not differentiable at a point if it has a cusp. What is a cusp? Like between two teeth. You can say here that it has a vertical tangent, the same thing. Vertical tangent at that point, or a corner, or is not continuous. So at which point the function is not differentiable, or I cannot find its derivative because it's undefined. So number 1 and number 4 are really the same. I cannot find the derivative because it's undefined. I cannot calculate the instantaneous rate of change of the function at that point. Or I cannot determine the slope of the tangent line at that point. They all mean the same thing. And where does that happen? When a function has a cusp like between two teeth, when it has a corner, when it has a vertical tangent, or it's not continuous. In all these situations, the derivative is undefined. I cannot find a tangent line at that point, or I cannot calculate the instantaneous rate of change, or the function is not differentiable. Everything is the same. Why do we need so many different ways of saying the same thing? I don't know. They are the same and they are interchangeable. Okay, so last time we looked at the graph. I don't remember which one, it doesn't matter. I think it was 27, but I'm not sure. So at this point, the function is not continuous. So it does not have a derivative. No one can find the derivative at this point or the slope of the tangent line because the function is not continuous there. At the other points is okay. At this point, it's a corner. No one can find the rate of change or the instantaneous rate of change of the function at this point because it has two. It has a slope this way and it has a slope this way. So which one do I use? None. It doesn't exist. Same thing at this corner. It's not differentiable. No one can find the rate of change at x4, x sub 4. The same thing for x sub 6. The same thing here. It's also a corner. It has two slopes, one going this way and one going this way. It's a corner. Here there is a vertical tangent. Okay? So now I would like us to look at an example. Find the equation of the line tangent to the graph of la 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 at a point. We don't have to repeat 3 times. It's a good practice, but once is good enough. So let's illustrate that this is very important to be able to find the equation of the line, the tangent line to the graph of a function at a particular point. In algebra, we needed 2 points. Here in calculus, we know more. So now we only need 1 point. So let's choose a problem from 17 to 22 and find the equation of the tangent line. At the given 1 point, you choose which point you want. If you don't,
do 18.
Yes. So find the equation of the line tangent to the graph of f of x. Very good. Awesome. So this is x squared. Can you please choose any point you want? 3, 9, negative 1, 1, or 10, 100. Okay, I will choose a 3, 9. Notice that 3, 9 is a point on the graph. So when x is 3, y is 9, of course. Good. This function is polynomial. Polynomial functions are differentiable everywhere. No problem ever. A polynomial function is always differentiable. I will always be able to determine its derivative. I will always be able to determine the instantaneous rate of change at every point. I will always be able to find the slope of the tangent line at any point. The derivative will always be defined. It never has a cusp. It never has a vertical tangent. It never has a corner, and is always continuous. So there is no discussion there. Okay, so I know that y minus y1 equals the slope times x minus x1, and I know that I have 3, 9. What I don't have is the slope of the tangent line. But this is given by the f prime. Given by f prime at 3. That's the slope of the tangent line to the graph of this function. I have to find f prime of x and then plug in 3 to get the slope. So, how do I find f prime of x? I only have one option for the next 10 minutes, and then I'll show you all the other options. Okay, the only option is limit as h approaches 0 from f of x plus h minus f of x divided by h. This is the only option for now, as I said, for the next few minutes, and then we'll move on to all the differentiation rules. We're going to move away from this definition. Okay, so as you remember, I have to find f of x plus h, but that's a piece of cake. Can anyone give us f of x plus h? Please, anybody.
It's x squared plus 2hx plus h squared.
Excellent. Very good. So, and you know my style. I'm too lazy to write the whole thing again. I'm kidding. There is no point in wasting time. So I'm jumping. So jump over all this and continue here. X approaches 0, as age approaches 0, from x squared plus 2x age plus h squared. This is this piece, minus x squared divided by age. Anyone remembers what has to happen as the first step? Mandatory, otherwise we can continue.
So you have to get all the x only terms out.
Anything that does not have age must go away. If some terms with age go away, it's even better. But all terms without age must go away. Okay, what would be the next step, a mandatory step? What do I have to do next?
Will we get rid of the h's from the...
Yes, so you have to go get rid of the age in the denominator, so we have to factor an age from the numerator. What is left?
Would it be 2x plus h?
Indeed. Good. Now please determine this limit. Remember, age approaches 0. Just the limit. And remember, this is a function. Good. So what do we get?
Is it just 2x?
That's it. So please remember, moving forward, x squared prime equals 2x. We're going to talk about this today. Good. So I found the derivative of x squared, which is 2x. Now I have to plug in 3. That's the x value. Please tell me what is the slope here. In other words, how much is f prime of 3?
6.
Thank you very much. Indeed is 6. Excellent. So this is our 6. And now in the next 3 seconds, 5 seconds, whatever, I will determine the equation of the tangent line to the graph of x squared at this point. Okay, so let's see how much this is. Let's stop for a moment. Any questions before we determine the equation? Was everyone with me? I don't want to lose anybody. Is this okay? Okay. Please speak up if you have any questions, please. Good. So I have y minus 9 equals 6x minus 3. Of course, I have to distribute 6x minus 18, and I have to bring a positive 9 over. So when I move a term from one side to the other, the only thing that happens is I have to change its sign. So it was negative here, it became positive on the other side. So then y equals 6x minus 9. What does this mean again? It means that if this is the graph of x squared, let's suppose this is the point 3, 9. The equation of the tangent line at that point is this, which is y equals 6x minus 9, and the slope of the line is 6. So this function at this point is increasing at 6, if it's kilometers, if the function is, let's say, distance. At this point, the speed is increasing with 6 miles per hour. Assuming that this is the distance function. That's what it means. Any questions? Okay, so I'd like to continue with one more problem here before we dig into the differentiation rules. Something like this. we're asked, where is the question? Never mind. I'll make it up if it's not there. So, I thought there was some information in addition to just this. Okay, there isn't. Fine. Draw a graph, which is a sample. There is more than one correct answer. Draw a graph that has horizontal tangent lines. So horizontal tangents at, so this is 35 on page 145. Horizontal tangents at x equals 2 and at x equals 5, and is continuous, okay, but not differentiable at x equals 3. Okay. So they want us to come up with a graph of a function that has horizontal tangents at 2 and 5. It's continuous at 3, but not differentiable. Okay. There are infinitely many correct answers here. So we want 1, 2, 3, 4, 5. 2, 3, and 5. So it says it has horizontal tangents at 2 and 5. You can do whatever you want, of course. I'm going to graph this. At 2 and at 5 and at 3, the function is continuous but not differentiable. So a horizontal tangent means the function either has a max or a min. So the slope here is 0. The slope here is 0. So as you see, I graphed a function with a max at 2 and the max at 5. And here I graphed a function with a cusp, or if you want, vertical tangent. Is it continuous? Yes, the function is continuous. But at 3, it has a cusp. No one can find its derivative. It does not exist. Its derivative at 3 does not exist. So we cannot determine f prime at 3. It does not exist. But can anyone tell us how much is f prime at 2 and how much is f prime at 5?
Would it be 0 because it's flat?
Absolutely. If the equation of the line is a horizontal line, or the equation of the tangent line is horizontal, the slope must be 0. Absolutely. So we're going to talk about this in the next chapter, actually in chapter 3. This is what happens when the derivative at the point, or the slope of the tangent line at that point, is 0. That's the derivative. It has a max or a min. There are other options. I don't want to jump ahead, so we're going to talk about this situation a little bit later. Excellent. Good. What about f prime of 3? What will you say? What will you write at f prime of 3? Anybody?
Undefined.
Thank you very much.